We are beginning our unit on quadratic functions. We're going to start with quadratic graphs and their properties to get a basic understanding of what quadratic functions look like when we graph them, how they are affected by different parts of their function, and just the different properties or different pieces of the graph itself. Now, the first problem that we're going to look at, there's some definitions. You should already have all of these written in your notebook along with your definitions and illustrations. But I'm just going to kind of point out a few that I want to look at for this first problem. First of all, this is called a parabola, not a parabola. That happens a lot. It is parabola, and that's the graph of a quadratic function. So again, you should already have that in your notebook. So when we talk about the parabola, we're talking about the graph. We're also going to be looking at vertex here, and the vertex is the highest or the lowest point on the parabola. And that vertex in this illustration, it is intersected by the axis of symmetry, and we haven't talked about that yet, but we will. So this is an example of your vertex. And then the minimum and the maximum. The minimum is the y-coordinate of the vertex of a parabola that opens upward. So if this opens up like this would be your minimum point right here. And maximum is the exact opposite. If your graph, your parabola opens downward, then this is your maximum point. So we're going to look at these definitions here in problem 1. This first picture, we've got to determine what are the coordinates of the vertex and determine if it's a minimum or a maximum. And this is probably fairly simple, but you're looking for either the highest point of the graph or the lowest point. Now, one question you can ask yourself is, can a parabola have both a minimum and a maximum point? And the answer is no. If the parabola opens downward, like this one, it has a maximum point, and in this case, it is 0, 3. That's your vertex. Think of this in terms of throwing a ball. If you're standing here and you throw a ball in the air, it's going to reach a maximum height, and then it's going to come back down. Okay, so a parabola that opens downward has a maximum point. So let's look at this example. This is a different picture, and we want to identify, is this a maximum or a minimum? And based on the last problem, you can figure this one out. This is a minimum, and it's a minimum at 1, -1. That's the vertex right here, 1, -1. And it is a minimum. Now, this isn't the best example, but one example you could have would be if you dig a hole. If you think of this as a hole, there is a bottom to the hole, and that's the lowest you can go. Okay, so that's the minimum point, and then you turn back around and go back up. So this is an example of a minimum, and the vertex is 1, -1. So now it's your turn. I want you to look at this one. I'm not going to give you any answer choices because I want you to do this without having the multiple choice there to refer to. But identify what the vertex is of this graph, and then tell me whether it's a minimum or a maximum. Now pause the video so you have time to do that. The correct answer to this is -2, -3. That should be very simple, identifying coordinates. And it is a minimum. This is the lowest point on the graph. So that is a minimum. Let's look at some graphs.
In this problem, you will graph a function of the form y equals a times x squared. Graph the function y equals 1/3 times x squared by making a table of values. What are the domain and range?
So we're going to graph just like we have with our linear equations when we were graphing those by making a table of values. So you should be familiar with that. Then we're also going to look for domain and range. We've discussed this several times when we were talking about functions. Domain is your x. What are the x values that I can use for my equation? And range are your y's. What y values will I have paired with my x's?
What are good values to choose for x when making the table?
Now, typically when we've been doing linear equations and linear functions, we would just use things like -2, -1, 0, 1, and 2. But getting into quadratics, because we've got a parabola, because our graph looks a little different than it has, we need to pick and choose our values to make graphing and to make this a little easier on us. So think about what values would be best.
Choose values of x that make x squared divisible by 3. so that the y values will be integers.
When you are multiplying by 1/3, 1/3 times x squared, it's the same thing as taking x squared and dividing by 3. Okay, the 3 is the denominator. You're dividing by 3. So what this is saying is whatever number you have on top after you square x, if it's divisible by 3, you're going to get an integer. You're not going to have to deal with all the fractions and decimals. So that's why you always want to think what is going to make this table easy to create the values and then plot and graph those.
Start with x equals 0. When x equals 0, y also equals 0. Now use x equals 3. When x equals 3, y also equals 3. And finally, use x equals 6.
Notice you're just substituting these values in for x.
When x equals 6, y equals 12. Now graph the function.
All right, so basically just plot all 3 of those points that you have, but that's not going to be your final answer.
Graph each point in the table.
Now, notice that they have marked this table off a little differently. This is by 3s, or the graph. This is 3, 6, 9, 12, 3, 6, 9, 12. So they mark these by 3s. So over 3, up 3, over 6, up 12. Now, my suggestion when graphing these, you've got an axis of symmetry, and that's what runs down the middle. And think about what it means to be symmetrical. That means that everything that's on this side of the graph has to match everything that's on this side of the graph. Now, we need to practice, for some, graphing not just 3, but going backwards. Think about -3 and -6. And if you can create the table with those 5 values, you will get all of the dots that you need. But if you understand what axis of symmetry means, then you can do what they're going to show you next.
Since this is a parabola, reflect the points from the table over the axis of symmetry, x equals 0, to find more points on the graph.
That means it has to be symmetrical. So notice I went over 3, up 3. I have to do the same thing on the other side of my axis of symmetry to keep everything symmetrical. This dotted line here represents your axis of symmetry. It runs through your vertex. So over 3, up 3.
The reflection of the point 3, 3 across the axis of symmetry is the point -3, 3. And the reflection of the point 6, 12 is the point -6, 12. Connect the points to complete the graph. The domain is all real numbers. The range is all real numbers greater than or equal to 0.
Now, the reason your domain is all real numbers is because I can use anything from 0 to positive infinity on the x-axis and from 0 to negative infinity. So I could pick any number I wanted here. As far as your range, notice that I'm not going below the x-axis. I'm not going down into the negative y's down here. So that's why y starts at 0 because that's where my vertex is. So y is at least 0 or more than that. Okay, notice it gets up to 12. It's going to get even higher the further we go up. So your range is y has to be greater than or equal to 0. It has to be any of these numbers heading towards positive infinity.
Now it's your turn.
All right, so here's your graph, or here's your equation. I want you to graph this function, and I want you to identify what the domain and the range will be. Use the last example, how they went through that process to help you. Now think about what could you use as your table of values to make this easier. Well, first of all, you don't have a fraction. You have an integer, -3. So you're not going to have to worry about division and getting decimals or fractions. So you could pick pretty much any numbers you wanted, but you need to start with 0 for this example. I'll tell you that. We're going to learn how to identify where to start later. But right now, start with 0 and pick 2 more numbers past that to create your table of values. Now, pause the video if you need a little more time, but your correct answer for this should look like this. 0, 0 is your vertex, and it is a maximum. Okay, our graph is upside down. If you used 1, you would get negative 3. And if you used 2, you would get negative 12. And then you could reflect that point over the axis of symmetry. Now, your domain's all real numbers because you could have picked anything you wanted to use for x. As far as the range, notice that we're not going into the positive part of the y-axis. So the range has to be 0 or less than 0 or less than that. So y is less than or equal to 0. It's everything below 0. All right, let's look at another example. This is comparing widths of a parabola. Basically, we're just trying to figure out what is the widest graph to the narrowest graph. And what's nice about this is there is an illustration that goes along with it. This is what negative 4x squared looks like. This is what 1/4 x squared looks like. And this is what just x squared looks like. This would be called our parent function because it's the easiest one. So this is the basic. This is the basis of all of our other quadratic functions, or all of our other parabolas. And notice what happens if I multiply x squared by 1/4. It makes the graph very, very wide. Okay, let's go back to x squared and notice what happens when we multiply x squared by negative 4. Well, first of all, it flips it upside down, but it makes it a lot narrower than the original graph. It's a little bit skinnier. So to put these in order from the widest to the narrowest graph, you're just going to look at what the coefficients of x squared does. Now, this is a good question that you need to answer. Does the sign of x squared, so positive or negative, does that sign affect the parabola's width? And it doesn't. It does not affect the width, okay? This was a positive, this was a negative, but the only thing that the positive and negatives are doing is flipping your graph, okay? Positive 1/4, positive 1. So positive numbers mean we're going to open up. Negative numbers, that means we're going to open down. So make sure you have that in your notes. Negative numbers will flip your parabola upside down. Positive numbers makes them open up. The only thing that affects the width of your graph is the coefficient. If your coefficient is a fraction, like 1/4, you're going to have a very wide graph. So that's the widest function we have. Then you have your parent function, because that's the original one, x squared. And then if you multiply your x squared by an integer, like 4, not a fraction, but just an integer, it's going to make your graph much skinnier. So it's going to be narrow. So that is our narrowest graph in this example. Widest to narrowest, fraction to whole number, or integer in this case. So think about what we just looked at there, how to compare widths. And I want you to take these 3 functions. You do not have pictures for those. So take those 3 functions and see which one is going to be the widest and which one will be the narrowest. Put them in order. Pause the video if you need a little time. The correct answer for this one is negative 1/3 x squared. That's going to be your widest graph. Remember, fractions make your graphs very wide. Negative x squared is the parent graph upside down, because remember, negative numbers make our graph go upside down. So it's still the x squared, it's just upside down. And then our narrowest graph there is the 3x squared, because we have an integer. Now remember, the sign does not change the width. The sign only flips it upside down or right side up. Positives are up, negatives are upside down. The fraction makes it a very wide graph. The integer makes it very narrow. And we'll discuss more about quadratic graphs and their properties in class.